Hey, what's up guys? Jake with Legacy 4x4 here again, and today we're going to be building a brand new plasma cutter. I actually sold my last one. I decided that I wanted to make a bigger, better, stronger, all around higher performance machine. So I sold the last one for about what I had into it, and now we're going to start on plasma table version 2. Alright, so bear with me as we go through this. This video might be a little bit longer, and that's on purpose. I'm trying to give more detail and lay things out in a much clearer sense than I did on the last one. So the videos might be a little bit longer. You can skip through or see whatever parts you want to see. There will be a bill of materials list posted at the very end of the video that shows everything that I have bought for this project, as well as a bill of materials list of the full project posted on Matt and I's new website. Alright, it's really hot outside and I'm dealing with electronics anyways, and so I decided I was going to build this inside today just to be in the air conditioning, and that way none of the components get dirt, dust, or anything on it like that. Alright, so we're going to start with a brief overview of everything we've got here to work with. I will be posting a complete bill of materials with each of these sections as we go along, so at the end of this video I will put up a screenshot of the version bill of materials for this version of the table build. And then Matt and I also have a website now. I will host the entire bill of materials on the website once the build is completed. So most of the smaller electronic components come from Amazon. Things such as like our start-stop switch, our emergency switch, all this kind of stuff. Again, we'll go into details of these as I use them. For the boards, we are using a Mesa THC board. So this is a Mesa 7i76E, which is an Ethernet control board for motion control and things of that nature. Came very well packaged. I'm not going to open it yet because I don't want to expose it to stuff. And then we're also using the Mesa THC, which is going to do the torch height control for this plasma table. All right, what else do we got in here? We got some standoffs, some plugs and pins, a label maker thing for the label maker. We've got, this is a power supply. We got cords, wires, limit switches, buttons, clickers, things, all this sort of stuff. Whole bunch of things that you will see again in the whole bill of materials and as we go forward to as we produce this. The overall idea here is to make this a very professional, very clean looking installation, much better than the last one. So I plan on using this metal NEMA enclosure that I got on Amazon as well for $100 or so. I'm gonna use this, I'm gonna put holes in it, I'm gonna mount all of these different, like I've got sockets, I got pins, I got everything that we need to mount onto this NEMA enclosure to make this look very, very, very clean when we're done. So we're gonna start with that. We're gonna start with doing the NEMA enclosure and some of the wiring, the inside of that, and then we'll start doing all the external stuff as well. So let's go and get started. So this is the box. It comes with a plate already ready to go that I'm gonna plan on using for all of my hookups, you know, all the like motor plugs, all that kind of stuff. And then I'll use this other face here for some static hookups that we'll never have to move. It's got a nice heavy duty door. It feels like it's made out of about 16, maybe 18 gauge, but it's pretty heavy duty. It's got this good little lip here. Anyways, pretty nice. All right, so all of my circuit stuff and all of my motors and all of that is coming from OMC Stepper Online. I've got a total of 4 power supplies here. 3 power supplies are gonna run the 3 big motors, and then 1 power supply is going to run the smaller Z-axis motor, and it's also gonna provide power to the Mesa boards and all that kind of stuff. I've got the 3 stepper controller, or the 4 stepper controllers here. Again, I'm using an all digital stepper from OMC Stepper Online to run the 3 big motors, and then a smaller driver to run the smaller Z-axis driver. I've got a 5-volt relay here, which I'll probably move somewhere, and then that's about it. I'm gonna run 2 big DC fans in here. Truthfully, probably only need 1, but I have 2 of them. I'm gonna go ahead and run 2 of them on there like that. One's gonna be in, one's gonna be out, so it'll hopefully flow air through the box to keep the whole thing cool. And then each of the power supplies has their own fans on it as well. I'm gonna build some kind of like leg structure or something to hold all these power supplies in place. And I'll build some sort of leg structure thing to hold all of these stepper drivers in place. I'm gonna do them like this up and down just for ease of packaging. If I had to do this again, I'd probably buy a wider box, but this is one of the cheaper ones that they sold, so I'm just gonna make it work. With all that said, let's go ahead and get started on marking up, and then we'll start drilling some holes and putting some things in place. All right, so of course I didn't record most of this. It's kind of boring, and I want to get into the actual good parts of this video that really show you guys some more details. So this is going to go inside of the NEMA enclosure, and as you can see, I've got a stack that holds all 4 of the drivers. I've got all 4 of the power supplies, and I've got 2 distribution blocks, which will come from the power supplies, and for grounds that will then ground into other stuff. This little tray up here is gonna hold a piece of plexiglass, and that's where the boards are gonna mount to directly on top of this in order to give plenty of room inside this enclosure for all the wiring. These pins do come out on these, they pull right out, so then I'll be able to wire them and then plug them back into their place when I'm finished, so I don't have to worry about screwing in things in this tight space there. And then these are offset to allow space in order to flip up these and then screw stuff into the power supplies as they sit. All right, we're gonna keep on going. Next, I'll show you guys the enclosure. All right, so we've got the physical layout of the board completely finished now. You can see I've got 3 of the drivers for the big 3 motors here. I have all 4 of the power supplies, and then on top of the power supplies, I have access to all of the actual wiring. I did it like this on purpose. The power supplies are the least frequently used, and then this now gives me full access to all the wiring, the relay, and things of that nature in the event that I ever have to replace anything. Now next, we're gonna move in and we're gonna start actually running some wires and start getting some things put together on the inside here. All right, like all things, steady progress. You can see how this is shaping up now. So far, I've not wired very much. I've kind of just done basic power at this point. I have the THC module, my 5-volt relay for the torch on function, and then the Mesa 7i76 here. Got an Ethernet port that runs from up here, runs an Ethernet cord to the back to plug into the Mesa, and then I've got 2 distribution blocks for grounding and power down here that I'm gonna run auxiliary stuff off of. So now we're gonna get into moving. We're gonna wire up some of this other stuff here, give the board power, start giving all this other stuff it's the power that it needs, making steady progress. Just like with my Jeep, when I wired that a couple weeks ago, as you guys saw, this is just a tedious process. You just gotta take your time. I listen to TV, listen to music or whatever, and I just slowly work at these problems as patiently as I can, because this does take a lot of time to do. But the wiring is pretty simple, if I'm being honest. Everything on the stepper motor drivers is very clearly labeled, so the hookups are very common sense and easy to understand. And then when it comes to actually wiring it into the Mesa control board, I've got a diagram for you guys that I'll show you how all of that stuff's gonna connect nice and easy. All right, we are making pretty good progress. So far, I've wired up a few of the drivers and what's gonna go on this panel here. You can see I've already cut or drilled this panel, which is removable, goes in down there. There's a total of 12 holes on this panel, 8 of which are for my limit switches and 4 of which are for my motors. I'm gonna be using these little microphone style connectors. The way these work is pretty simple. On the back side here, you can see there's 4 pins. Those 4 pins are going to be connected using a piece of 4 conductor wire, and that's going to run into the various stepper motor drivers. These little pins here then fit through these holes like so, and then they lock down in the rear using one of these. There you can see how that's going to look. I'm going to do this for all 4 of these, and then these ones, all 8 of the limit switches are just a 3-wire connector. Moving into what actually plugs into the stepper motor drivers. So you can see each of the drivers has, I'll show you right here. Each of the drivers down here at the bottom, these particular drivers have A+, A-, B+, and B-, and then they have the volt DC ground, volt DC and ground. This is what's going to go to the motor hookups. And then up here you can see I've got the direction, direction minus, direction plus, pulse minus, pulse plus, and then enable. I won't be using the enable function, but I will be using the 4 direction and pulse functions up there. Those are going to run to the Mesa board over there, which I'm going to get to in a little bit. So for now, all we've got thus far I have positive and negative power hooked up, and now I'm going to start running the conductors to the panel, and I'm going to start plugging these into their respective power supplies. You can see on this side, this is how this looks. It uses, these are the other ends of the connectors. They plug right in and then screw down simply with your fingers to make a nice tight connection. I will wire all of these using the rest of the conductor wire once I get to the actual build of the table, but for now, the casing is done. This gives it a much cleaner, nicer look than the last one of these I built, which is why I went this way. So I have all of the motor controls here, all the limit switches over there. So now it's time to move on to actually wiring the mesa board. I'm gonna try to get this wired up today. I am following this wire diagram, which I'm gonna put on the screen right now, and you can follow along kind of with the basic idea of how I'm doing this. I found this wiring diagram on one of the Linux CNC forums. It's pretty comprehensive and it's pretty easy to understand. Truthfully, these are not that complicated to wire. They're mostly straightforward once you look at a pin diagram and you know how to plug things up. Anyways, let's move on. We're gonna follow the wiring diagram I just showed you guys, and we're gonna get into the next part of this, which is actually wiring up the Mesa controller. So the THC module, which is right here, has a total of, looks like 6 pins on the back side of it. On the far right, there's an N negative, and on the far left, as you look at it here, there's an N positive. The Everlast documentation on the back of their pin here says that pin number 6 is divided voltage positive and pin number 4 is divided voltage negative. I've got those wired up, red for positive, black for negative, and that will run along the case and then plug in right here. The rest of this plug here, we gotta wire in the arc OK signal and the start signal, which is what turns on the plasma cutter. So let's go and do that. All right, I've got the CNC port fully wired and screwed into the case over here, as you can see. It just bolts in right there, easy enough. I've got one little wiring harness that runs along the back side here of the case and plugs into my 5-volt relay here. I'm using this relay to turn the plasma cutter on and off. This is an easily replaceable relay. I did the same thing on the last plasma cutter. Easily replaceable with screw-in connections. I bought a 2-pack of them on Amazon, as you'll see on the bill of materials. For inputs to the relay, I'm using just off of the distribution blocks that are down there, a positive and a negative, and then the output signal. The output signal comes off of the output for the Mesa board, which is here. It's this blue wire, runs over there, output signal. So when it gets a signal from the board, it should kick out and turn this relay on, which will then close the contacts through the CNC port to the machine. Got another harness that runs along the back here and up and plugs into the bottom of the THC card, which provides the divided voltage to the THC card. I'm going to use 1/16 divided voltage because that's what the Everlast motor comes with. If I have to change it for some reason, you can change it inside the plasma cutter itself, but for now I'm going to go with what they have stock. I'm going to plan my software off of that. Last bit, this yellow wire here goes straight down and hits onto the red distribution block for positive power, and then the green wire transfers over to this input pin on the Mesa board. What that does is that provides positive power to the arc OK signal, which comes from the plasma cutter. It'll provide positive power, and then on the back side, this is the signal wire. I called Everlast. It's pins 9 and 10 on the CNC hookup on their machine is what uses the arc OK signal. It doesn't matter which of the 2 pins you use, but one pin needs to be positive voltage input and the other needs to be the signal output from the plasma cutter. All right, we got this box completely finished, and I'm gonna end the video here, but first, let's go over a quick overview of what we've done, how it all looks, and some of the design features I added, and why I went those ways. That way you guys can hopefully do one of these yourselves. All right, so starting from the outside, and then we'll work our way into the box here. On this panel here, we have 3 total plugs. I've got a plug for the CNC port coming off of my Everlast 62i power plasma machine. I have an Ethernet port down here. So you plug the Ethernet cord into here from the computer, and that's what runs into the Mesa control boards and how it gets its signal from the computer. And then back here, we have a generic 3-prong power cord. It just uses a generic cord, and then it's got a fuse and a power switch, which provides power to the entire system. Moving over to the front face here of the Yuko box that we're using, this had a pre-cut panel that was able to just slide right in, and then I drilled in holes for a total of 12 pin connectors on this face. On the right here, we've got 8 limit switch connectors, and on the left we have the 4 motor connectors. The limit switches are a minimum and a maximum on each of the 4 axes that we're using. There's 4 axes, and this A axis is actually the Y2 axis. I'm just calling it A because that's what Linux CNC codes it as, and so it'll be easier for me to like match things together on hardware and software, which we'll get into in the next video. Over on the motors, we've got the X, Y, Z, and A axes as well. Everything is labeled and clean. Granted, my little stickers aren't perfect, but it's all labeled so it's for easy identification as you plug things in, you know what goes where. On the bottom of the machine case here, I have 2 fans, one going in, one going out. These are just 2 little DC fans. They run off of one of the additional power supplies, and these are going to provide the airflow within the case as it operates, in addition to the 4 fans that are on the individual power supplies. All right, moving on to the inside of the box, and this is going to be like nearly impossible for you guys to see, and so I'll point to stuff, but I will have an updated wire diagram available for you if you wanted to see how I plugged everything in on the inside here. So starting from those plugs that we just talked about, this is the CNC port here, and then below it is the Ethernet port. The CNC port runs, it's got 2 leads that go to the bottom of the THC module, 2 leads that go to the relay, and then 1 lead that goes to the output here, or the input here, and that's for the ARC OK signal. The Ethernet cord is at the bottom there, and then just a 3-foot Ethernet cord runs along the inside of the case and then plugs into the back of the Mesa card over here. All right, and then we got the power switch, which is back there, you can't really see it, and that runs and provides constant 120 volt power, which then feeds each of the 4 individual power supplies that are located down here. Each of those power supplies are all wired the same. 3 of the power supplies run each of the 3 big motors on the machine, and then the last power supply runs the smaller motor, and it runs all the auxiliary stuff such as the distribution blocks, the fans, the limit switches, things like that. We've got a stack over here on the right on all these black boxes here. These are the 3 big motor digital stepper drivers, and then we've got the Z-axis, the small NEMA 23 stepper driver right here. I picked up all of these stepper drivers and the stepper motors and the power supplies from Stepper online. They came as a complete kit to run a machine like this. I bought a 3-axis kit to run the bulk of it, and then I just added another 1-axis kit for the Z-axis because we're doing a dual drive gantry system. All right, down here on the bottom left, we have the THC AD10 card from Mesa. That Mesa card is what's going to be able to take the raw voltage, the divided voltage from the plasma cutter, and it will then turn it into an input that the Linux CNC can read. So it takes in the divided voltage on this side, and then on this output side, it pushes out to the encoder on the Mesa, and that's what then we'll get some data values for, and that's what's going to run the THC, the torque height control on this plasma table. Using the THC card like this is a cleaner, better solution that should provide higher performance versus something like the Proma THC that I had on my last one that I had a lot of issues with. And also added benefit is this little card is only $70 versus the Promas are nearly $300. It does require more coding and more software work, but we're going to get into that in detail on the next video. And at the end of the next video, I will actually have a full downloadable file available for everybody that wants to just use the file that I created. So it'll save you a bunch of work at that point. And then this back panel here is where all of the step and direction output signals from the board go. So there's a total of 4 of them, 0 through 3, and that's gonna run all of the different motors. So I've got it going X, Y, A, and Z, and I'm just using standard wiring to just plug it all in. All right, as far as design and material choices go in this, I did use a lot of 4-conductor wire here. As you can see on the bill of materials list, I just bought 100 feet of it and I just used a bunch of it. It's all 20 gauge wire. It all fits nicely on the inside with all these connectors that the Mesa cards use and all the separate drivers use. And then also it's nice and it's already shielded and protected, gives it a nice clean look on the inside. I used a bunch of these little self-adhesive zip tie tabs. I have these all over the inside of the box in there, and those are helping to pin a lot of the wiring down to the edges of the box and things like that to keep it nice and clean. And then I did a bunch of little 4-inch zip ties all over the place to provide a lot of structure and safety to all of these wires. I try to minimize the strain that's put on the wires, so there's like zip ties everywhere as a reinforcing method to help provide a lot of simplicity and clean look to this, even though I know it looks kind of messy. That's about it though. It's not too complicated of a project. It did take me 3 days to do, and most of that was because I was fabricating like these little, like the raised mounts that all this stuff sits on, like this little angle piece that stack sits on. I was fabricating those, and that took a little bit of time to get everything right and get everything lined up. That's it though guys for today's video. I hope you enjoyed that. Again, I know I cut out a lot of like the just me working kind of footage, and I focused instead on trying to get you as much information as possible. If you have questions, feel free to drop them below, and I will absolutely answer those whenever I can, as frequently as I can, to help you guys build your own table and your own electronics enclosure as well. The total cost in this enclosure was like $1,200, including like the box, all the electronics and everything like that, which is not that bad considering that it would cost you like $2,500 to $3,000 to buy one of these enclosures from one of the companies that sells them. If you're not comfortable doing all this small wiring and you're not comfortable setting all this stuff up, then just go buy one of those enclosures and then you can do the rest of the kit, the rest of this design yourself. The mechanical stuff is going to be super easy. Like I said, hopefully this gives you guys some motivation to do this yourself. This table, although slightly more expensive than my last one, is going to be much higher performer than my last one. I think we're roughly looking at about $4,000 in material on this one, and the last one was like $3,000 if you wanted a perspective on that. So I think it's worth the extra cost though. I am using bigger motors, better drivers, and all that kind of stuff, which added to the cost, but it's going to be a much higher performance, so take that into consideration. I hope you guys like that. Stick around for more. We're going to have probably 4 or 5 more videos in this series as we build this second table, and it's going to be a lot more detailed as we go forward to really help you guys be successful here. I hope you guys like that. Make sure to like, share, and subscribe, and